think before I get into the nitty-gritty of solving this problem, I just want to give you an overview or a big picture of the problem and of the math behind it. So in the economics side of the problem, the fact is that the price of something depends on, in one case it depends on how much of that something is available, which is the supply, and the price also depends on the demand. So they've told us in this particular case that the price increases as the supply increases. So this blue line, and they've also told us that it's a linear function right here. So this blue line is going to represent how the price behaves as the supply increases. That graph represents supply. On the other hand, they've also told us through the numbers that they've given us that as the demand for this commodity increases, the price happens to change as well, and it just so happens that it decreases. Don't worry about how I know that for now. But that's what that graph would look like. So the price changes depending on the supply. It also changes depending on the demand. In both cases, it changes at a constant rate, at a linear function. And at some point they meet. Supply and demand are equal, and that is the equilibrium point. So in question A, they're asking you to figure out the rule for the blue line, which represents how the price changes based on the supply. And in part B, they're asking you to figure out the rule or equation of the green line, which is how the price changes with the demand. And in question C, they're asking you to figure out where those two lines meet, what we call the equilibrium point. So we'll start with part A. Since it's a straight line, all you need to figure out what that line looks like, and therefore what its rule looks like, is 2 points. Any 2 points on that line is enough information to figure out everything you need to about the line. So they've told us, they've given us 2 points actually, in kind of a veiled way. They've said that when the supply is 7,100 millions of bushels, so I'm just going to put 7,100, the price is $2.24, which is this. By the way, I'm not drawing this to scale, so these may or may not be in the right place. They've given us another piece of information, though. They've said that when the supply is 7,500 millions, the price goes up to 231 per bushel. So just those 2 points give us enough information to detect the rate at which this blue line is increasing. We can see that the price went up by 7 cents when the supply went up by 400 bushels. So it's changing at a rate of $0.07 per 400 bushels. So now we know that in the rule for that blue line, the first number here multiplying the x will be whatever 0.07 times 400 comes to. So we've got half of the rule. All we have left to find is this number here, which is, by the way, wherever that blue line touches the initial axis. So just visually, you can kind of see that now that we know that it goes up by 7 cents every time the number of bushels goes up by 400, you can kind of see maybe that if we work our way backwards and go back 400 bushels and down 7 cents, and keep doing that until we work our way all the way back to the y-axis, we can uncover how much the B is. So, I mean, you could do that on the graph, but it would be a real pain. Or you could do it algebraically, like this. You can reason like this. We can say, at this point, and say, well, that price of $2.24, that must have come from this multiplying the x, the 7100, plus some number b. And all we need to do now is work backwards and uncover how much the b is by just solving this equation. So you've got 2.24 is equal to, and this whole thing, enter my calculator, comes to 1.2425. So 1.2425 plus some number b gives 224, so we just have to subtract those two. 425. And for b, you end up with 0.9975. So just so you can visualize this 0.09975, it represents the number that we would have reached here, 0.9975, if we had done, backing up from this point here. If we had gone back 400 and then down 7 and back 400 and down 7 and just repeated that until we got all the way back to 0 bushels, this is where we would land on the graph. So that's how you figure out the rule for the blue line. So I just tidied this up a little bit. So now we've got the rule for the blue line. You can do the exact same procedure for the green line because they've given us 2 points on the green line as well. I told that when the demand is 7,700, the price is 231, and when the demand is 7,800, the price is 224. So we can see that when there was a change of 100 bushels, the price actually went down by 7 cents. So that means that in our rule, for the green line, it's going to be y equals negative 0.27 times the number of bushels plus, again, call it b, that's going to be, in this case, this number here. And we can do the exact same procedure, like, reason that if I change the demand by 100, if I go back 100, then going back in time, the price must be going up by 7 cents. And keep doing that until we reach the price when there were no bushels. And again, you can do it either on the graph and get a giant pain in your neck, or substituting the point, one of these 2 points, it doesn't matter. You can say, well, the $2.31 must have been the result of this number getting multiplied by 7,700 bushels plus some number b, and then a little bit of algebra to solve that gives you that number must be $7.70. I mean, visually it makes sense because it's much higher than the other one, and you can see that certainly if it started out at 770, you can see that sure enough it did come down pretty considerably from there for the green. So here's the rule then for the green line. Again, it's got negative 0.07 over 100 times x, and then plus 770. And just to make things look a little neater and less confusing, maybe you could of course just punch this into your calculator. It'll give you a decimal number, and if you'd rather write it that way, sure, it would look like y equals 0.000175x plus 0.9975, and the other one, I would do the same thing for that. That gives you y equals a negative 0.0007x plus 7. So that means, as far as the supply goes, that even when there are 0 bushels available, the price per bushel will still be this, but every extra bushel we get will go up by that much. And even when there are 0 bushels available, the demand, even when there is 0 bushels being demanded, the price for that commodity will still be $7.70 per bushel. And as demand goes up, the price will go down by this much per bushel. So you can see that they're headed in different directions. So it makes sense that they're going to meet somewhere. part C is to find the place where you need them. Again, you could just graph them accurately on a piece of graph paper and then just look at the point where they meet and read it off of the graph. As usual, there's an algebraic way to do it, which I'll show you now. This algebraic method capitalizes on the fact that at this red point, whatever the numbers are in that ordered pair, those numbers will work in the blue equation equally as well as they will in the green equation. We also know that whether I look at the x-coordinate here as belonging to the blue line or the green line, it's the same number, and the same thing is true for the y-coordinate. In other words, the blue line is at exactly the same height as the green line at that red point. And in algebra, height is represented by the y-coordinate. So in other words, we know that at that red point, the blue y is equal to the green y. So I simply take this side of the blue equation and this side of the green equation and set them equal. So it's 0.000175x plus 0.9975 equals negative blah 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 blah. Now it's pure algebra time where you bring the x terms all to the same side. So I've brought this one over, and when it changes sides, it changes sign, so it's positive. And then the non-x terms move over to the right. Once again, this one changed sides, so it changed sign. Now I combine them. You end up with this after you combine them by doing this number plus this number, the x. 770 minus 775, and then of course you just divide both sides by this really, really tiny number, and you end up getting an x of 7660. So that tells you, looking back at the graph, that this red ordered pair here has an x-coordinate of 7,660. Visually it looks about right. We were expecting it to be something bigger than the 7,500 and less than the 7,700. So all we need now is to get the second part of the ordered pair, the y-coordinate. So basically we're trying to figure out how high the point is when x is 7,660. And as I mentioned before, it's the same height whether I look at it as belonging to the blue line or the green line. So we capitalize on that by plugging that x, that value for x, into either one of these equations, and it calculates for us how high the point or the y is. Plug it in, like plug in that 7660 into the blue equation, and fire up the calculator. Yeah. And I'm getting y equals 2.338. So that means that when the number of bushels is 7660, which is at equilibrium, the price will be $2 per pound per 2.338. And what's nice about these problems is you can always check if you're right by just by mistake. So you can always check if you're right by taking that x and plugging it into the green equation as well. And if you get the same answer for y, it's pretty certain you can take it to the bank that your answer's right. And I've already done that, and I can tell you that it does.